from the analog to the digital age. Digital. Computers use digital signals, zeros and ones, often done. All the data that a computer processes is a series of zeros and ones. Each signal is a bit. Analog. Most phenomena in life are analog. Analog signals use wave variations. Sound, light, and temperature are analog forms. Traditional TV and radio use analog signals. Humans' vision operates in analog mode. But analog data can be converted into digital form. Even though digital data is not as exact as analog data, it is easier to manipulate. For data transmission over telephone lines and cables, modems are needed to convert analog data into digital data that computers can use. Modem is short for modulate/demodulate. Modems modulate, convert a computer's digital data to analog data, transmit it, then demodulate, reconvert it back to digital data for the receiving computer. Modems can convert data by modulating either an analog wave's amplitude or its frequency. The continuous, even cycle of an analog wave is either converted to digital form through frequency modulation or analog wave. Frequency modulation means the frequency of the cycle increases to represent 1 and stays the same to represent a 0. Amplitude modulation means the height of the wave is increased to represent a 1 and stays the same to represent a 0. Converting reality to digital form. Sampling. Tape recorders, voices, and musical instruments are analog, CDs are digital. To burn a CD, the digital recording equipment must convert from analog to digital. The analog to digital converter samples the sound and converts the height of the wave to a number. Samples of the sound wave are taken at regular intervals about 44,100 times each second. Because the digital samples are played back faster than our ears can react, it sounds to us like a single continuous sound wave. Digital sampling is similar to showing movies. Movies show still pictures called frames. But they show them so fast that our eyes can't react in time, so, to us the series of still pictures look like continuous motion. What's a network? Network is a system of interconnected computers, telephones, and/or other communications devices that can communicate with one another and share applications and data. Benefits of networks. Share peripheral devices, such as printers, scanners, disk drives. Share programs and data. Better communications, including email. Security of information, because of improved backup systems. Access to shared databases. WAN, Wide Area Network. Covers a wide geographic area, such as a country or the world. Largest one is the Internet. MAN, Metropolitan Area Network. Covers a city or a suburb. LAN, Local Area Network. Connects computers and devices in a limited geographic area such as an office, a building, or a group of nearby buildings. HAN, Home Area Network. Uses wired, cable, or wireless connections to link a household's digital devices. PAN, Personal Area Network. Uses short-range wireless technology to connect an individual's personal electronics, such as cell phone, PDA, MP3 player, notebook PC, and printer. Home Automatic Network. Relies on very inexpensive, very short-range, low-power wireless technology to link switches and sensors around the house and outdoors. Two principal structures of network. 1. Client-server. Consists of clients, which are computers that request data, and servers, which are computers that supply data. File servers act like a network-based shared disk drive. Database servers store data, but don't store programs. Print servers connect one or more printers and schedule and control print jobs. Mail servers manage email. Two principal structures of network. 1. Client-server. Consists of clients, which are computers that request data, and servers, which are computers that supply data. File servers act like a network-based shared disk drive. Database servers store data, but don't store programs. Print servers connect one or more printers and schedule and control print jobs. Mail servers manage email. Intranets, extranets, and VPNs. Intranets use infrastructure and standards of the Internet and the web, but for an organization's internal use only. Extranets is similar to intranets but allows use by selected outside entities, such as suppliers. VPNs or virtual private networks. It uses a public network, usually the Internet, plus intranets and extranets to connect an organization's various sites, but on a private basis, via encryption and authentication. Regular Internet users do not have access to the VPN's data and information. Network components. Wired wireless connections. Wired are twisted pair, coaxial cable, fiber optic cable. Wireless are infrared, microwave, Wi-Fi, satellite. Hosts and nodes. Client/server network has a host computer, which controls the network. A node is any device attached to the network. Packets fixed-length blocks of data for transmission. Reassembled after transmission. A packet is also called a datagram, a segment, a block, a cell, or a frame, depending on the protocol. Protocol. Set of conventions, or rules governing the exchange of data between hardware and or software components in the network, built into the hardware or software you're using. Hub. Common connection point for devices on a network, has multiple ports, and can send to all connected devices. Switch. Device that connects computers to a network, sends only to intended recipients. Bridge. Interface that connects same type of networks. Gateway. Interface that connects to similar networks. Router. Special computer that directs messages among several networks. Backbone. The main Internet highway that connects all networks in an organization, includes gateways, routers, etc. NIC or Network Interface Card. Inserted in a slot on the motherboard, enables computer to operate as part of a network. NOS or Network Operating System. The system software that manages network activity. Network topologies. Bus. All nodes are connected to a single wire or cable. Ring. All nodes are connected in a continuous loop. Star. All nodes are connected through a central host. Packet collision schemes. Protocols. Collisions happen when two data packets are going opposite directions on shared media. Ethernet deals with LAN collisions. All devices send data at once. Collisions happen regularly. Data is resent until it arrives. Token ring avoids LAN collisions. Devices take turns sending data. Token is sent around the ring. Wait to get the token, then send data. Communications media carry signals over a communications path. Twisted pair wire. Two strands of insulated copper wire twisted around each other. Twisting reduces interference or crosstalk from electrical signals. Data rates are 1 to 128 megabits per second. Coaxial cable. Insulated copper wire wrapped in a metal shield and then in an external plastic cover. Used for cable TV and cable Internet electric signals. Carries voice and data up to 200 megabits per second. Fiber optic cable. Dozens or hundreds of thin strands of glass or plastic that transmit pulses of light, not electricity. Can transmit up to 2 gigabits per second. Have lower error rate than twisted pair or coax. More expensive than twisted pair or coax. Lighter and more durable than twisted pair or coax. More difficult to tap into than twisted pair or coax. Wired communications media for the home. Ethernet. Pull Cat5 cables through the house. Connect to PC's Ethernet Network Interface Card or NIC. For several PCs, get a hub or switch to connect them all. Speeds of 10 or 100 megabits per second. Home PNE. Uses existing telephone wiring and jacks. It requires home PNE, NIC, in your PC. Speeds of about 320 megabits per second. Home plug. Uses existing home AC electrical lines. Speeds of 200 megabits per second. Electromagnetic spectrum of radiation is the basis of all telecommunications signals, wired and wireless. Radio frequency spectrum, or RF, is the part of the electromagnetic spectrum that carries most communications signals. The radio frequency spectrum, which carries most communications signals, appears as part of the electromagnetic spectrum. Bandwidth, range, or band of frequencies that a transmission medium can carry in a given period of time. Analog bandwidth is expressed in hertz, digital bandwidth usually in bits per second or bps. Narrow band or voice band is used for regular telephone communications. Its transmission rate is 1.5 megabits per second or less. Broadband, for high-speed data and high-quality audio and video. Its transmission rate is 1.5 megabits per second to 1 gigabit per second or more. TCP is the protocol for getting wired devices connected to the Internet. WAP, or Wireless Application Protocol, gets wireless handheld devices, such as cell phones, connected to the Internet. 5 types of wireless communications media. Infrared transmission. Sends signals using infrared light. Frequencies are too low to see. 1 to 16 megabits per second. Broadcast radio. AM/FM, CB, ham, cell phones, police radio. Sends data over long distances using a transmitter and a receiver. Up to 2 megabits per second. Cellular radio. Form of broadcast radio. Widely used in cell phones and wireless modems. Transmits voice and digital messages. Microwave radio. Super high frequency radio waves, 2.4 GHz or higher. Requires line-of-sight transmitters and receivers. More than 1.5 of today's telephone systems use microwave. Communications satellites. Microwave relay stations in orbit around the Earth. Basis for global positioning systems, or GPS. Cover broad service area. Communications satellites can be placed at different heights. GEO, MEO, and LEO. GEO, geostationary Earth orbit. 22,300 miles above Earth. Travel at the same speed as the Earth, and so appear to us to be stationary. It's always above the equator. Transmission delay can make conversations difficult. MEO, medium Earth orbit. 5,000 to 10,000 miles up. LEO, low Earth orbit. 200 to 1,000 miles up. And is no signal delay.